This tiny creature is a navigation powerhouse. It has an internal pedometer that counts its steps and a compass sense, allowing it to always know its position relative to the nest. The researchers built a spiking neural network, which is basically a low-power, brain-like chip to act as the robot's internal pedometer. This thing is super robust. Even when external sensors are getting noisy data or failing, this internal sense of self keeps tracking. So the robot never loses its fundamental understanding of where it is. But an ant's internal compass isn't enough for everything. And that's where the second system, inspired by migratory birds, comes in. Birds are the ultimate multi-sensor navigators. They use the Earth's magnetic field. They can see polarized light patterns in the sky. They use the sun's position, and they recognize landmarks. The robot version of this uses a quantum magnetometer, a super-sensitive device that detects magnetic field direction, polarization compass, to see the sky like a bird, and a standard camera. All these inputs are fed into a smart algorithm called a Bayesian filter, which dynamically fuses all this data together in real time. The magic is in the redundancy. If the camera gets blinded by dust, the system doesn't panic. It instantly leans harder on the magnetic and polarization data, and the robot keeps on course. They build cognitive maps in their hippocampus, but they're not constantly updating every single detail. They only revise their mental map when something important changes, a new obstacle, a moved landmark. This is genius because it saves a ton of energy. The robot mimics this by building a map only when it encounters a significant landmark. This is a massive upgrade over systems like SLAM simultaneous localization and mapping, which constantly update the map, draining power and processing resources. This rodent approach keeps the navigation stable and efficient, especially in cluttered, chaotic places. Imagine a search and rescue robot driving through a collapsed building. It's dark, dusty, and the GPS is gone. Its camera might get blocked, but its internal ant pedometer keeps counting its wheels' rotations. Its bird magnetometer keeps it oriented, and its rat brain only updates the map when it passes a crucial beam or doorway. It's a robot that navigates with the robust, fail-safe ingenuity of an animal. The neural networks are pre-programmed, but they want to put actual, on-chip continuous learning directly into the hardware, using things called memorystive synapses. This would allow the robot to learn and adapt in real time, just like a real brain. They're also aiming to scale this up to create kilometer-scale cognitive maps. This is a fundamental shift toward creating truly autonomous robots that don't need us holding their hand. It's about building machines that can think, sense, and navigate with the resilient, multi-layered intelligence of the natural world. It's a glimpse into a future where our machines are a little less machine and a little more alive.